Okay, you've seen the rules for existence, you've seen the rules for all. Now we're going to use them together to try and prove this statement here. So what do we have? There exists a y for all x, p of xy. And from that we're trying to prove for all x, there exists a y, p of x comma y. So first off, intuitively y is true. Let's suppose p of xy is a statement x is friends with y. X is friends with y. So what does this statement here mean? There exists some person y such that for every person x, x is friends with y. So there is some person y that's friends with everybody. And we want to prove from that statement, for all persons x, there exists some y such n is friends with y, namely this friendly buddy from above. Okay? So we write the thing we want at the bottom and the thing we're given at the top, like we normally do. Okay? And here's how I tackle these problems. I break up the for alls from the bottom using for all introduction backwards, and I break up the existences from the top working down by existence elimination. So let's deal with this term first. The only way I can prove for all x exists a y, p of xy, is showing for an arbitrary variable a that there exists a y, p of a comma y. So I've just replaced the x's with the a's, okay? So now what? Well, I've got the existence statement here, so the only way to get from here down to here is by using this rule here, existence elimination. So I need to show that by assuming for a new arbitrary variable, so I can't use a, I've already used a, I'm going to assume for a new arbitrary variable b, if I assume this statement with the y's replaced with b's, so if I assume for all x, p of x comma b, and I obtain this statement here, q, then I can get q down here. And here I got to check my new variable b is not free in here. Well, y is present and y is bound. A is present and a is free, but that's okay. I only care about b. Is b free in this? Well, b isn't even present in this, so it certainly can't be free. So this condition here is not violated. If you violate this condition, you can prove all manner of silly false things, so don't. Okay? So I need to somehow get from here down to here. And the gap in the middle is not too bad to fill out. If I have for every choice of x, p of x comma b is true, then I can choose any x I want, namely a, by for all elimination. So I have given for all x, p of x b, I have p of a b. Well, if p of a b is true, then there exists some variable y such that p of a y is true. I can just replace the b with an existence, right? If it works for b, then there exists some y such that it works by existence introduction. So the gap is filled, so let's fill in our line numbers, complete the proof. 4, 5, 6. That's given, that's an assumption. This is for all elimination, line 2. Existence introduction, line 3. You gotta be careful here, this is the tricky rule. Existence elimination, where is the existence that we eliminated? It's this line up here, line 1. Line 1. And then what is the assumption block? From here down to here, 2 through 4. Okay? And then how do we get this all here? This is for all introduction. We showed for an arbitrary a exists a y, p of a y. That means for any choice of x exists a y, p of xy. So that's going to be for all introduction, line 5. Not lines 2 through 5, not lines 2 and 5, just line 5. I know that's confusing because normally when you see this line here, you want to quote this entire block. But here we made an assumption, we quote that assumption. Here, no assumption was made. We denote assumptions by a horizontal line. So we only quote line 5. Okay? And that's the proof.